Stoichiometry. Coefficients in a chemical equation represent the number of molecules of reactants and products in that particular reaction, but they don't represent the mass of those molecules. We don't want to count molecules on our reactant side and our product side because typically we talk about large numbers of molecules. Counting is done by weighing. The issue that arises, though, is that our reactants and products are going to be different substances. And since they're different substances, they're going to have different atomic masses. So the question arises, how can we compare the compounds in a chemical reaction? We're going to compare them by using moles. So let's look at an example. Let's say we've got 12.5 grams of C4H10, which is butane, and it's burned in air. Well, that's a combustion reaction. We know that it's oxygen in the air that the butane's going to react with. So we've got C4H10 plus O2 as our reactants. We know that in a combustion reaction, we're going to produce carbon dioxide and water as our products. Our question wants to know how many grams of carbon dioxide is formed. Well, an unbalanced equation is not going to give us the ratio of molecules that react in that particular equation, so we're going to have to balance our equation. We have 4 carbons on the reactant side and 1 carbon on the product side. So if we put a 4, that'll balance our carbons. We have 10 hydrogens on the reactant side and 2 hydrogens on the product side, but 5 times 2 will give us 10 hydrogens on each side. If we look at the product side, we've got 4 times 2, which is 8 oxygens, plus 5 times 1, which is 5 oxygens, and that gives us 13 oxygens. We can't put a whole number in front of oxygen on the reactant side in order to balance this out. So when we end up with an odd number of a particular element on one side and an even number on the other side, we're going to double all of our numbers. So we're going to put a 2 here. That's going to make this an 8. That's going to make this a 10. And now we've got 16 plus 10 oxygens, so 26 oxygens. If we put a 13 here, that'll give us 26 oxygens. So now we have a balanced equation for our reaction. We have 12.5 grams of butane, and we want to find out how many grams of carbon dioxide. Well, the balanced equation tells us that for every 2 moles of butane that reacts, 8 moles of carbon dioxide are going to be produced. So we're going to be able to relate butane to carbon dioxide by using moles. We start with 12.5 grams of C4H10. Our first step is going to have to be to convert grams to moles. So we look up the molar mass for butane off the periodic table, and we get 58.14 grams of butane for every 1 mole of butane. That will cancel out grams of butane. Now we look at the balanced equation. For every 2 moles of butane that reacts, we're going to produce 8 moles of carbon dioxide. Moles of butane cancels out using that mole ratio. We don't want moles of carbon dioxide in our answer, though. We want grams, so we're going to have one more step in our stoichiometry problem. For every 1 mole of carbon dioxide, we need to know what our molar mass is, which is 44.01 grams. We'll take the numbers on the top and multiply, take the numbers on the bottom and divide. We have 3 significant digits in the value we were given, so we're going to want to round our answer to 3 significant digits. So 37.8 grams of carbon dioxide are produced when 12.5 grams of butane are combusted in air. Let's look at another problem. This time, it gives us the balanced equation. We've got silver nitrate reacting with potassium bromide. We're going to produce silver bromide and potassium nitrate. We're looking at a double displacement reaction. And for this reaction, one silver, one nitrate, one potassium, one bromine, so it's a balanced equation. That means it's a 1 to 1 to 1 to 1 mole ratio. So our question says we've got 64.18 grams of silver bromide is formed from how many grams of silver nitrate? Well, again, the balanced equation tells us that for every 1 mole of silver bromide that's produced, 1 mole of silver nitrate must have reacted. We start with 64.18 grams of silver bromide. And in our first step, we're going to convert grams to moles. So we look up the molar mass for silver bromide, 187.77 grams of silver bromide for every 1 mole of silver bromide. Grams of silver bromide cancels out. Our balanced equation tells us that for every 1 mole of silver bromide that's produced, 1 mole of silver nitrate must have reacted. And we don't want moles of silver nitrate, we want grams of silver nitrate. So our last step, we're going to convert from moles of silver nitrate to grams, and we look up the molar mass. So 169.33 grams of silver nitrate in 1 mole. Multiply the numbers on the top, divide the numbers on the bottom, and we find that 57.88 grams of silver nitrate had to have reacted in order to produce 64.18 grams of silver bromide. So remember these steps. Make sure to write and balance the chemical equation first. If you're given grams, convert it to moles. Use your mole ratio from the stoichiometry in the balanced equation, and then convert moles back to grams.